Now next is type of potential energy. There are two types of potential energy I have discussed. Gravitational potential energy. So expression for gravitational potential energy. It is work done against gravity in moving an object or body. So consider an object of mass m and it is supposed to be lifted to a height h. We have to do work against this gravity. So here work done is given by force into displacement. Force into displacement. Force is force against gravity, mg, into displacement, that is h. So this work done is stored in the form of potential energy, that is gravitational potential energy. So potential energy is now indicated by capital U. So expression of gravitational potential energy is mgh. H is the height up to which object should be lifted or bring down. If it is brought down, then potential energy is changing into kinetic energy. If it is moving up, then kinetic energy is changing into potential energy. This is gravitational potential energy. Now, at the surface of Earth, H is 0, so potential energy is always 0. This is work done by the applied force. If it is work done by the gravitational force, work done by gravitational force, then potential energy will become minus mgh. That indicates that work is done against the gravity. Minus sign indicates, negative sign indicates work done against gravity. Now next is elastic potential energy. What is elastic potential energy? Or this is also known as potential energy of a spring. Because this is in terms of gravity, so it is known as gravitational potential energy. Elastic potential energy when there is linear displacement or horizontal displacement. So elastic potential energy or potential energy of a spring can be defined as here when a spring is stretched or compressed, then the work done is stored in the form of potential energy with the spring. This is known as this energy is known as elastic potential energy. This is elastic potential energy. So here we need to have expression for potential energy of spring. Here you can see a diagram where I am taking a spring. This block is attached. When you apply a force, it generates a restoring force, and displacement is along this direction. This restoring force will bring this block or spring, because I am stretching it, it will compress back. So this force and displacement x is having some relation. What is that relation? That relation is given by Hooke's law. Hooke's law in elasticity. Hooke's law says that restoring force is directly proportional to extension in the spring. Extension in the spring. Directly proportional to negative of extension in the spring. So here F is directly proportional to negative of displacement, which means that if you open this, we will get a constant minus kx, where k is a new term. You have seen that in dimension. K is known as spring constant, which depends on material of a spring and temperature of the spring. Spring constant has unit of K is Newton per meter or dyne per centimeter. But spring constant depends on temperature and density, that is material of the spring. It is also known as force constant, spring constant or force constant. Now, when the restoring force developed, then a force is required to balance it. So work done by external force. So external force is required to balance this restoring force. External force F1 is equals to minus F. Minus F means F1 is equals to minus kx. So that is kx. Now for small displacement, for small displacement dx, dw is equals to F1 dx. This is work done by the source, by the external source. So it is kx dx, putting the value of F1. Now again, for large value, for total value, integrating dw is equals to k is constant, x dx. Now again, see, if displacement is 0, then no work is done. If displacement is x, then work done is w for complete extension. Now here you will get integration as w, 0 to w, k, x, 0 to x. So here you can see w is equals to k x square by 2. I am doing it directly. Now you can see, putting the value of this, this is x square by 2. So the expression for potential energy, elastic potential energy, is half kx square. This is the expression for elastic potential energy, where k is spring constant, x is extension in the spring. Now there are two questions for Google form. Google form questions. You have to write the answer. Question number 1. Google form for physics. Question number 1. When a body performs circular motion, then what is the work done equals to by centripetal force. This is your answer number 1. Now question number 2. Find the dimension of K, spring constant K. This is your answer number 2. So this is all for the energy part. We will discuss conservation of energy and examples of conservation of energy in the next class. Thank you.